Hello everybody, welcome to my backyard. I apologize for my less than professional dress. This is my lab creation clothing. So what I'm working on is a permeability lab for earth science or physical science. I'm adapting a lab that I have created and modified over the years that was very successful. It was the best lab of the year. This is a version of it that I think can be doable in at least some of our facilities. So this is where I'm at with it. I made some trial runs today. So basically, a few things. So there are two different size sand sediments here. This is a larger size sand. So this is like very coarse sand, which I collected in Montauk, Long Island, actually. And the other sand, and I've sorted this, is finer sand. It's still pretty coarse sand, but it is smaller. So there's two sizes, large and small. And we're going to be pouring water through them, or students will be pouring water through them, and then timing them. So some of the materials, I know the materials are of great importance that they are secure, not contraband. So I think maybe this is okay. So what I have here is an old cranberry juice container. I cut off the bottom. I have a rubber band here, a rubber band that keeps on some window screen. Okay, this window screen may be vinyl, it might be metal, but there is vinyl as well. That would work. I could get vinyl. There's a rubber band on here. If rubber bands don't work, I've used a zip tie before, and a zip tie also works. So this is pretty straightforward. I'm trying to use materials that are easily acquirable. And the other thing, and I know it's really challenging, most facilities don't have water in a room. I know it's difficult. So the way that I would propose to get around that would be with buckets. Here I have a bucket here with water in it, and then you would probably need a second bucket for like wastewater to be dumped in. So the basic idea is what I have here. I'm not sure if you can see it. I've marked with a Sharpie the same spot on the containers for each of them. So we're going to pour our sediment up to that level, so it'll all be consistent. So for instance, what I have here, and then the setup goes like this. So this has some of the coarse in there, and I've been doing a trial there. So this has some of the coarse sediment in it. And what I have, because I have limited materials here, I'm just at my house, I don't have a lot of lab materials here, unfortunately, is I just took a clear container and I marked a line on it. Now, also could be used is plastic beakers. At my previous school, we had a bunch of, I think it was 1,000 milliliter plastic beakers, which is just about this size. So that could be good too. And then you could perhaps have, you know, the mark of 200 or 300 milliliters. That was what the sort of target volume is that students are timing. So that is the basic setup. And again, you have two of those and the sand itself. So the way that it would work is you would get, or students would go to the bucket of water and get some sort of transfer mechanism, another beaker perhaps. You'd go like this, right, and pour it into this container. Now this could be your beaker, it could be, you know, 800 milliliters. This is just happens to be in ounces. This is what I have around, but that could be good for measuring. Hey, students, get it right up to 800 milliliters or 900, whatever that number might be. You could do that. And then what we could do, or the idea is this, and I actually don't have a timer because I was using my phone, but my phone is now taking this video, so you can't use a phone. Obviously, it would have to be a stopwatch. That would be something that I would probably have to, through home office, acquire some basic stopwatches that I'm hoping are not considered to be against the rules, contraband. So that's probably the one thing, now that I'm thinking about it, might be a bit of an issue. Okay, so here we go. I have this water here. So I have 24 ounces of water. It would be, just to be consistent every time, whatever that volume is, that to be consistent. And then I have it set up like this, and I purposely did these containers because they kind of sit in there. Normally use a ring stand, can't use a ring stand. So, and then I have this line mark here. So the idea is we're gonna pour this in and time until it gets to there. Now I do have a timer now. I got my old phone out. Let me see, right? So I have my stopwatch out, and the idea is this. Now, so here we go. You kind of pour it basically all at once and you stop it. This is good if kids can work together. That's great, but they can do it on their own, as I'll do here. So especially if you have a stopwatch, you just push it. You don't have to like look at it or be like a phone. So I go like this. I go, wait, let me go back to here, and I start it right there. Pour all the water in, and then I am watching until it goes up to the line right there, and then what do I got right there? Okay, so that was 10.08 seconds, which is pretty much in the same range I was getting in the 9s before. I did it a number of times, and the idea is then the students would probably have to put this in another one like this and let the water drain out, dump this out. So that's what the waste bucket will be for. So dump it in the waste bucket, let the water drain out. The directions would probably say let it sit for, you know, another 60 seconds or something so the water would drain out. Then what you could do, or I mean, the idea is you do this here, right? You go back and you do it again. It's pretty reproducible. You'll get a number that is in the same basic range, you know, especially with the sediment in the 9 probably or 10 seconds range. It goes pretty fast. This is a larger size sediment, and you know, we could have students do it 3 times, 4 times, 5 times. It's just good to, you know, they really like the hands-on nature of it. And then you get into getting an average. So that's always like good for the math skills, average, rounding. So it's good for that. And yeah, then you would get the smaller size sediments and do the same thing. And you do that again, a number of trials, whatever that might be. It might be 2 or 3 or a certain number, and then get them to average it, write out all the work. Really good for their, you know, again, math skills, calculating skills. Then the next part of it is when you're done with it all. So it's going to be messy. I'm not, you know, you're going to have probably 2 buckets of water. If any of this was to spill, you know, that just gets all over, but you know, just sweep that up. And then what you need to do is you know, at the end of the day, what I've always done is you take the sand here and I dump it out, and then you really want to like spread it out and have a lot of surface area on it. Usually on old newspapers, actually a thick layer of old newspapers of, you know, 5 or 6 pages. It works really well. It absorbs the water. It will dry generally overnight. The larger sediment dries much faster. And then I usually pick up the newspaper and I fold it and I dump it back into the container, which I usually have a bucket. So the drying is definitely part of it. It is definitely an issue. You need a place to do that. Then a second part of the setup can also be used for another lab, hands-on activity, but I would consider it a lab, for porosity. How much water can be stored in between these particles? So what I took is some of our smaller sand, right, 2 sizes, and what I did is I took the screen off and I put the cap on there so water won't flow through, right? So the same amount, I have the sand almost up to there, or I want it up to the line. I'm a little short, but it would be, you know, tell students fill it up to the line, or teachers can do it, but students really like that sort of measuring, just the hands-on. I think that our students really need it. I'm really trying to get our students to do something hands-on. I know that it's hard. So the idea here is going to be, and this, this is the first time I've ever done it with this exact sediment in this setup. So the idea is they get and I would like to have a, you know, again, a metric beaker, like a plastic beaker, right? And we would have to figure out what that number is. Start with, I mean, you can start with 1,000 milliliters, right? And you have to pour it slowly in, really slowly in. And the idea is you got to kind of, it's kind of good to watch. You could, I don't know if you can see it here, but watch the water infiltrate down. And the idea is you tell students to pour slowly until the water gets right to the top of the sand. Now, this is a little bit of there's definitely a bit of an art to it. And actually, this is a better setup. I've done this before with the settling tubes, and that's a little more challenging to see because you can't look in the top like this, really. But usually looking at the side, but I can't even really see where the water is right now. Oh, there we go, right at the top. There's a little bit of water at the top, so we consider that the sediment is completely saturated. And the idea is then if you started with, let's say, 1,000 milliliters, and now you have 600 remaining, the students have to then determine how much water, what's the porosity. In this case, it would be just the volume of porosity here. So what I say, start with 1,000, end up with 600, it's 400 milliliters, for instance. And they would, write that down for the smaller sediment. And then you do the same thing with the larger sediment here, okay? And then you pour the water and find the porosity of larger sediment, which is a good activity. I started just doing this in the last few years, and kids just like the manipulation, the hands-on. It's hard because what we have to teach them really is that the porosity, if they're rounded and sorted, is going to be the same. They're never going to get it to be the same. But that's a teachable moment if you can speak about it. You never want, you don't want to have the misconception if this is larger, this is smaller. But I still think it's a good process for them to go through. It is using the same basic materials, which is good. The issue here is that once it gets wet, you can't use it again. It has to be dry, obviously. So you just have to be after the other lab and the sand is all dried. Again, that's a bit of the challenge, just material wise, but just so and I could send all this material. The sand I'm continuing to sift through it. That's where I'm at. Porosity and permeability labs.